All right, so let's get started. Today we have another special guest, Robin Ranjit Singh Chauhan. Robin is not a Amii student or faculty, but he's a regular attendee of all our tea time talks. He loves thinking about RL and has been asking a lot of insightful questions, not just to us, but many RL researchers all over the world. And today he's going to tell us about his background, his podcast, and his other interests. Go for it, Robin.
Thanks so much, Abhishek. Thanks for having me here at Amii. It's a real pleasure after being a fan of yours, of Amii Tea Time Talks for a long time. So this talk is TalkRL and some other projects. I was told you have to start with a joke. So two Amii students are named Value Function and Policy are taking a US history class, and they're learning about John F. Kennedy. The bell rings, and as they're leaving, Policy turns to Value Function and says, sounding very superior, you know, you really should ask not how much your state can do for you, but ask what action you can take for your state. The trade-off with my jokes is they might not be very funny, but they're original and they're very personalized. So I hope you appreciate that. So yeah, I do TalkRL podcast for the past year. And so the inspiration for that was really, I was noticing that the interviews with researchers were very kind of more shallow for the general audience, and they weren't really focused on RL. I found the Q&A and discussions parts at conferences were too short. And I'm not affiliated, so I don't get to have these chats with people. I had a chat with Evan Raka of Mila after Neurips 2018 in a cafe, randomly in a cafe. And I was like, wow, was so nice to chat with someone about RL. So I'm like, how do I do this more often? So I was forced to start the podcast because of that, basically. I also thought it would be good recon, you know, if I decided to do a PhD later, because I find this area quite interesting. There's also an element of desperation because like there's just so many papers, and how do you know what's important? So I thought it would be great to go right to the source. So the guests so far, you can see on the right, I was very lucky to have your own Chaba as a guest, and hopefully we'll get some other Amii people as guests before too long, hint. But yeah, I've been super blessed to have amazing guests and learned so much from each of them. Who am I? Well, my main role is actually head of engineering at a VC out of San Francisco that focuses on agri-food tech. So I ended up doing data engineering, machine learning on tabular data and text data. And I started on AI really young. When I was 15 in the Himalayan mountains, I was doing back propagation by hand, not by hand, in C. But you had to write the back propagation back then. Genetic algorithms, and I also was really into low-level code. I was a very nerdy kid. I did computer engineering at Waterloo, and then I did a bunch of various jobs, some of which had machine learning, some of which just a lot of data-intensive stuff. And in terms of coming to RL, you know, I encountered DQN and AlphaGo in the media, really, and DQN in Nature, and then I started reading Rich's book and watching lectures, reading archive, and basically once I realized what it was doing, I was just like, wow, this is really cool. Everything else became much less interesting, and it basically I went back to being a teenager again, which was my happy place. So there's in Vancouver, I'm in the Vancouver area, and there's a Kaggle and data science group here, and so I joined them and got into deep learning that way with a lot of them actually. And then I getting into RL, I gave some talks there. We formed a RL reading group there. And then in 2018, I did the Neurips Pommerman competition. So I don't know if you guys were there at Neurips 2018, but that was quite a good time. Memorable moment was dancing with Rich at the after party. You can see a picture below. But the Pommerman competition Pommerman's like this game based on Pommerman. And so I made this agent for it, and I did a lot of crazy things for the agent. When I talked to other people, their agent design were a lot more simple. So I think I kind of went overboard in some ways, but I really wanted to do not just a vanilla model-free thing. So I ended up with a model-free / model-based thing, and I'm not going to go in detail on this, but it was a really big project for me. And I learned a ton from that. Many lessons I learned from that are still relevant today. Affect my work today. And I just want to point out the CNN design for that agent was mostly from Ross Whiteman, who's world class at CNN. So credit for that. So yeah, in terms of this elephant down here and the blind men are me. After every episode, I'm one of the different blind men, thinking that RL, now I think RL is a rope, and before I thought it was a table. But what is it really, right? So what I found is that one of the things I've learned from doing the podcast is it seems like everyone you talk to has so many different assumptions baked in to how they define the RL problem and the solutions. And so you get a very different notion when you talk to different people. And this is one thing I'm really enjoying about it, is getting these very diverse points of view. There's too many things here to list, but I can just say a couple things. I mean, settings is such a broad phrase that encompasses so many things. But I've noticed different camps have very different approach to function approximators. Some people, if it's more of an afterthought. For some people, it's the main thing. And then there's all these different preferences and what they're trying to go for. And then different camps have very different notion of what is important in terms of these things like uncertainty, whether causality is relevant, how important is generalization, whether they care about small data or not. So I think of RL, now I think of RL as settings and approaches, but I also think of it as like a social network. And I'm hoping to get more perspective on that through the podcast. So I'm going to talk about some of my guests and some of their work. Just a disclaimer, it's an embarrassing position to try to explain what brilliant people are doing. So if I say dumb things, it's definitely my mistake and not theirs. My first guest was Natasha Jaques. She was kind enough to roll the dice on a show that had no track record yet. And she had just come out with this paper at the time and was finishing her PhD at MIT on social influence as an intrinsic motivation. So she was looking at these problems called sequential social dilemmas, which is basically like prisoner's dilemmas, but extended through time. So in this case, for example, I think this is a gathering one, but basically situations in which if the agent only acts greedily on its own, the whole society suffers and everyone suffers. So they have to find some way to work together. And these are kind of analogous to the situations we find ourselves in climate change and different realistic situations in real life often have this property. And so DQN doesn't solve this on its own, or like general agents don't solve this on their own. But what she did was create a new type of intrinsic motivation, which basically did this counterfactual and said it would create a model of other agents, so it could predict what other agents would do, and then it could think about, well, if I do that versus I do this, how would it affect the other agent's actions? And it was a new way to encourage cooperation and coordination. So that was pretty cool. And there's this whole area of research that she was building on that I was not aware of. And I think SSDs are totally central to what many problems we have today. So that was very interesting to me. Scott Fujimoto was another guest. He's famous for inventing TD3, the improved version of DDPG. And he's done a lot of great work on batch RL, including batch constrained queue algorithms. So with his paper, off policy reinforcement learning without exploration, I think it was called, he brought to the forefront the idea that, what if your batch is missing some data? And that kind of expanded my idea of the setting. Like it was like a new type of set. I mean, not new, but new to me, and a very different emphasis. And so I learned a lot from talking to him, and actually get to work with him once in a while. So I've been really excited to read his papers. I actually sought him out because I cared about that setting, and I thought, well, what better way than to talk to the person who's basically expert on it. And then Taylor Killian was my latest guest, and he focuses on machine learning for health, and so he's doing RL in a health setting, and they care about very different things in health. So a couple of examples are hidden parameter MDPs, which are basically if you have a set of MDPs that are very similar but not the same. And his example is like if you're learning how to write with pens, and pens could have different weights and lengths. I mean, the real example is different patients, right? They had different responses, but they were similar but different. So you're learning how to deal with the whole series, a set of MDPs, and you're learning how to quickly customize detect and customize to the MDP that you're in within a single episode. And so this is showing his latest version of this, direct policy transfer, which is adjusting in a single episode, adjusting to the how it figures out this MDP is working. And then another example of a recent paper of his using counterfactual inference to improve policy iteration in a medical setting. So basically, if you're in a hospital and there's tons of data on this hospital, and you can learn from that, but then you go to another hospital and maybe the patient population is very different, the distribution is very different. You have a distributional shift there, and you have very little data there. How can you quickly adjust using this other data? And he's saying you can do that with the causal model. So that was pretty interesting too. So these are just a few examples of guests. What are my things that I'm doing right now in terms of RL? So the podcast launched last year, and that's ongoing. And then I'm working on an RL project, applying RL at a leading digital health company in the States. So that's an offline setting. And I'm actually advised by Scott Fujimoto McGill and a few other researchers in other domains. And then I attend conferences and Amii tea time when I can, and I do various experiments after hours. Let's see, I don't know how we're doing for time. Oh, we're okay for time. Okay, so I'll just touch on a few other things. So here's a couple of gyms that I set up as basically test beds for different things. So the one on the left is, and this one's kind of why I wanted to talk to Taylor, because so here's CartPole. I basically took the OpenAI CartPole and then just modified it so that you could customize all these parameters like gravity and the mass and length of the pole, and so you can make all these variations of it. And so what I did here is so these lines are the different factors, the changes in the different factors, and right in the middle would be the MDP, the standard CartPole. And then if you follow this blue line, the blue line is gravity. What happens when you log factor is so going down to 0.1 gravity, 0.01 gravity, or 10 times gravity, 100 times gravity. So these lines are, if you vary one parameter, how does this agent, this happened to be a PPO agent, how does an agent that was trained to perform perfectly on the original CartPole, how does it perform when you modify that parameter to that extent? And so this is trying to give an idea of how robust the agent is to modifying different parameters and helping me think about, okay, how do you make agents that would be robust to that? And on the right is a test bed for distributional RL, is to say, what if just a way to make, in this case it's bandits, how to make stochastic bandits that produce mixed distributions for the rewards. So the blue arm has this bell, this normal distribution here and a spiky normal here, and the red arm has a uniform distribution in this section, and so you can kind of just customize that. I mean, it's a simple thing, but you need these test beds, and so that's so I use that to try to test certain things. Here's another experiment I was doing to get to know the properties of LSTMs as a function approximator. And in this case, what I'm doing is just, again, parameter sweeps to see how do these LSTMs deal with sequences of various lengths, of various widths, of different data set batch sizes. And so, for example, in this one, you can see, it's hard to see, but the sequence length is along the bottom here. So this is saying for very short sequences, when it jumps up to yellow, that means it's learned, and the training progression goes along this way. So this is saying if it's a very short sequence, it learns right away and stays yellow. That means it's accurate the whole way. If it's a very long sequence, it just never learns it. And as you increase the sequence length, you see there's some point where the performance just falls off. That's sequence length around 25. So to me, that was interesting to see that LSTMs are really having trouble around that length. Here's same with the feature count. You can see as we make the feature vector wider and wider, it gets harder and harder for it to learn. And then here I'm looking at batch size. So this is the on this axis. This one's a little different. The training's on this direction, but it's saying the log of the batch size. Basically, you need your batch size. If you're doing it in a batch way, you need a certain size batch before it'll learn anything at all. If the batch is too small, it just can't figure out what the pattern is at all. Anyway, just okay. So here's Pommerman agent. I was this is partway through training. So the kitty is my agent, and these agent smiths are the scripted enemy. And so the kitty's trying to kill the other agents. And And this is partway in training, so it's doing okay, but it's not, right now it's not very aggressive. But you can see this is kind of what the gameplay looks like. And here's another project. This is kind of like an art project at this point, policy of love. So it kind of looks like a hippie thing or whatever, but really, like Stuart Russell was saying, here's a quote from Stuart Russell: "If the obligation of machines is to try to optimize the aggregate quality of human experience, how would they know what that means?" So this is me thinking about, like, what do we really want in a reward function? And rewards being so easy to game. And I mean, I guess I'm using the symbol love as like in well-being and compassion sense, and I'm thinking of it as the impact of the agent's actions on humans and the biosphere, but not about the agent's well-being or feelings or rights or anything like that. This is me thinking about, well, if we, in the future, if we have all these policies and they're being guided by these reward functions, and we could have all sorts of agents, tons of agents everywhere, and they're all going to be using rewards that are kind of like gameable rewards, and it just seems like a really bad idea in some way. And so I was just thinking about what would it take, so in Pommerman, I did a lot of reward shaping. That was one of the non-standard things, is I customized the environment to emit many types of events more than just win and lose, so that I could, if I wanted to, I could shape the reward with that stuff. And then I was thinking, if we had a real agent, like let's say you had a policeman robot or something, this is kind of relevant. What would you put into, what would you want it to care about? And so I was just thinking about externalities, like, the environments. We always think of environments as kind of something in a vacuum, but in reality, they're not like that. And so I don't know if there's any solution to it. I just think of it as a koan. It's just something I look to sometimes for inspiration. And I put it on a T-shirt just to make me think. That's basically my talk. I'm surprised I did it early. Oh, I have one more joke, actually. Okay, let's see if we can do. So Optimus Prime walks into a bar, and the bartender says, "So what do you want?" Optimus says, "I'll have what they're having," and he points over to OpenAI 5, which are 5 guys sipping from a giant barrel through these huge fat straws. And the bartender calls to the back really loud. He's like, "Bring out another endless rollouts." I can't really see you guys, so I have no idea if everyone's completely puzzled by that one, but I'll end it there. Thanks so much. Yeah, if you guys have any questions, I am here still. Let me stop sharing here.
Yeah, I have a question, maybe a compliment phrase as a question, which is that you've got this really nice podcast where you're talking to people from sort of different communities and these different camps. My question is, besides listening to your podcast, what advice do you have for all of these different camps to sort of become more aware of each other and, just like become more cosmopolitan and talk to each other more?
Oh, that's a good question. I don't have an easy answer, but I think one thing I noticed at the conferences is, like, I was kind of an outsider when I went to Neurips 2018, and I was looking around, I'm like, everyone's like in little huddles with their team people. And so I feel like conferences is one of the few times when you get to see people from other teams. So why would you choose to just huddle with your own gang the entire time? Like that, I'm not saying particularly Amii, but just every group was like that. And so I thought it was strange. I'm like, when do these people meet other teams? This is their only chance, and they're mostly with themselves. So I felt like maybe that could be one thing. Yeah, I feel like there's, I also feel like during question periods in general, people don't really ask a lot of questions. Like, I'm kind of annoyingly verbose in my questions, maybe to the extreme, but some, okay, at Neurips, some of the best papers I've ever seen, like absolutely earth-shattering stuff. And then when they say any questions, then everyone's just silent. And I'm like, what the hell is going on here? Like, this is your chance to talk to the best people in the world. Why would you miss that? So I guess just getting in people's face, people love to talk about what they're doing. But when I first got into it, I thought people would just not be so friendly. And I thought they'd ask me, like, who the hell are you? Why are you asking me about this? But they're not like that at all. People want to talk about their stuff. So yeah, great question, Roshan. Thank you.
I had a quick question. Since you've talked to a lot of people, which industries are most excited about RL?
Ooh. I would probably say none of them. Like, no one really knows what the hell it is. Like, I talk to some, I don't know, like every time I bring it up, people are just like, what's that? Like, even my friends from computer engineering, like, unless you're really following stuff, like it's not really a known thing as far as I can tell. And like, so like I'm in VC, so I see startups that use machine learning, but I haven't seen anyone using RL. I mean, it's harder, right? It's way easier just to use some like YOLO or something. Yeah,
So
it's a good
people
question. I think, pardon?
Sorry, go ahead.
I mean, I think it could be used in a lot of places, but I think I think it also requires a lot of imagination to see where it should best be used. But it seems to me like, to me, I'm really interested in, right now, I'm really looking at how the health, people who are focused on medicine and health are looking to apply it, because I think they really care about the real world. They have consequences that are real consequences if it's wrong. They care about uncertainty. They care about it being correct. So it's like just a different level of care. And so I'm kind of looking to them for inspiration for all the other real life stuff for those reasons.
Right.
Yeah, actually, yeah.
So people don't know about it, or they don't know about good examples or good cases where it actually helped, or people don't even know what RL is. Or like, what is RL? It's ML. Oh, you're misspelling it or something.
Yeah, I think it's all of those things. I can't speak for everyone. I don't really know. Like, I'm not really serving the industry of people, but in general, outside of where you would expect to meet RL people, I've never met anyone who's heard of it.
Thanks.
So I'm also interested to hear who people think should be on the podcast or whatever. I think if I'm lucky, maybe Martha will come on soon. But if there's anyone in particular, I'm always open to. Actually, I'm always open to critiques, and it's very hard to get critiques on anything. People either say that's very nice, or they don't say anything. And so critiques is even better. Like, something could be better, or yeah. Anonymous critiques, yeah, of course. If you want to, yeah. Yeah, thank you for the jokes. The jokes are original jokes. You will not find this. This is original content, people. Nowhere else. Have debates. I like that. How would that work? Who would debate? Matthew. Depends on the topic. Yeah. I mean, I will say, when you go to the conferences and you see like two very smart people arguing, that's I get to popcorn and I'm like, that's the best time. I'm ready. Because like, so one time I saw Sergey Levin and David Silver arguing about reward functions. That was the best thing ever. That was in, I think, ICML. Oh, Grand Neurips Debate 2019. What was that?
It was like a social where like they just have like a group of 8 researchers split up randomly and discuss about whether the machine learning field is stuck in at local minima. It was have like a social, have like a debate, and it was super fun.
I don't know how I missed that. I guess I'll have to find it on, if you can ever find anything on Slides Live.
I think it wasn't recorded, but it was hilarious.
Cool. Yeah, I love hearing people disagree, especially people who know what they're talking about. That is the best thing. So, hey, if you know any two people want to argue, I would love to cover it. Yeah, I think that the one I was speaking of, David Silver and Levin, was about whether there should be a reward function at all. I think Levin was saying you could just do away with the reward altogether in the sense of using exploration, and I think Silver was saying you do want some kind of reward. I don't know. Dopamine. Okay, so tell me about that. You mean the framework?
No, I was just saying you can't do away with the reward because we need dopamine. That's the whole point, right?
Ah.
Yeah, you can't do away with dopamine. That's how you get Parkinson's.
Okay, I didn't know that. So if you don't have dopamine, you get Parkinson's?
Yeah, it's used all over the body, but yeah.
So we should not expect an RL framework named Parkinson's, basically.
Well,
That's amazing.
That was a bad joke. The dopamine author was on the podcast, but I don't know anything about dopamine. So what you're saying is dopamine is our reward signal is it for novelty? Is that right?
Well, I don't know the brain that much. Jeez. Yeah, dopamine, like the RL reward system is modeled after the dopaminergic reward system. So we get reward in the signal of dopamine. Like that's the neurotransmitter that gives us the good feeling when we do certain things, and it plays a big role in addiction and stuff. So I'm thinking like if RL is modeled after that system, then we do need a reward signal because it's all founded on the role of dopamine and reward and those things. But in other brain regions, like motor regions, it's used for like walking initiation. So kind of that like first step kind of thing. So when you don't have dopamine, you get freezing gait, where like people with Parkinson's, they won't be able to take a step, say like across a threshold through a doorway and stuff like that. So like it plays lots of roles throughout the body.
Interesting. Okay, that's really cool. I think, I mean, to me, that raises the whole question of should we, and I know this has been explored before, but to what extent should we model AI after what we understand about the brain versus, because some people I think who are maybe doing more work with exploration and not really trying to make it map to how our brains work. So maybe both are valid approaches.
Yeah, my thoughts are like a lot of people get in arguments over which learning system's better than the other. Like, should we all be doing RL? Should we be doing supervised, unsupervised, other things? And, like coming from some of the neuroscience background, I think, if humans, we don't learn one way, we learn in many ways. And so I think if we're looking at AI and solving real world problems, then we probably don't have one solution or one algorithm either. I think that's one thing I've learned throughout all my studies is there's never one solution to anything, because as soon as you find something that you think works for everything, there's all of a sudden a case that it doesn't work for. So I think, yeah, like exploration, exploitation, I think there's a reason why there's a dilemma and maybe why some people favor others like one over the other, but I think it all depends on your task and what you want to accomplish.
Yeah, Matthew's making comments about this. Different parts of the brain do different things. Different parts of our agents should do different things. Yeah, I totally agree with that. And how far can you take that? I guess in the deep learning world, it's easy to stick on all sorts of deep learning components. But then when you try to connect something outside of that world, like knowledge bases or other things, then it's not always clear how they would fit. Maybe that's solved, but to me, it's still a little confusing how to connect those other things in.
Hey Robin, could you tell us a little more about the RL project that you're working with right now with the healthcare company? Like as much as you're allowed to, of course, but yeah.
Yeah, how much can I say about that? Well, it's not a, I can say it's not a critical care type of situation. It's not like an ICU type thing. It's more about getting patients on a healthy lifestyle. And so the agent is there to help coax / encourage patients to improve their lifestyle. And so it's kind of early phases right now, but I've been guiding the company on how to generate the kind of exploration data they're going to need, how they can incorporate bandits to be a little bit smarter about how they reach out to people, and then moving up to full RO. Yeah. Does that help? I don't know if people are interested, but I could say a little bit more about the Pommerman agent, just because I put so much time into it. And it's, to me, I actually really liked it. I can be kind of brief, but the idea with this agent is that there's all this mechanics to the environment that's like semi-deterministic. So there's like this complicated, if you look at how the bombs go, there's this, the bombs can be sitting, but they can also slide, and they have these small explosions, but later on the explosions get bigger, and the bombs have a timer on them. And so there's a lot of complications with the bombs in terms of how do you know when a bomb's going to explode, and how do you know where the flame's going to go? Later on, the bombs get really big, and it's hard for the agent to predict all this stuff. So you can see some of these explosions start getting larger, right? So what I did there is I made a model to predict where the bomb blasts would go, and that was this Futron. And so I tried, but it was a partial model in that I didn't try to predict everything in the world. I just tried to predict the bomb stuff. And then I basically offloaded the difficulty of knowing where the bombs would explode and when and how large to this thing, and then it would do a multi-step prediction where it would predict frames into the future where the flames might be. And then it was also multi-resolution because it had, at some point it would start to combine frames and say, well, for those following 5 frames, I think there could be flames here and there. Yeah, and then to me, so it actually didn't, I didn't win the competition. I didn't perform that great. I won a few games, but it wasn't enough to rank super well. But I wanted to do it this way because I wanted to learn a lot more, and I felt that this approach was actually tackling the core of the problem directly, which is the most complex part. So I made some there was a couple bugs that I found partway near the end of the training when I didn't have time to retrain, and so there's a couple reasons why I could see why performance was as great as I wanted, but this still influences me to this day. I think the idea of separating, and hearing like Rich talk about that, and also Haddo Van Hassel from DMind talk about that was actually influential to me on this design. Eric says, I don't want my agents to be based on humans. Humans are dumb. I agree, Eric. We are dumb.
We should have an argument about that sometime. Sorry, a debate about that sometime.
A debate. Are humans too dumb to be the prototype for intelligence?
Should our agents be based on humans or not? Should we incorporate human biases and things that we know work in air quotes, or should we not be looking at humans as our inspiration for algorithms?
Yeah.
What do you think?
I think it depends on what you're trying to do. I mean, for me, with this agent, I built in all these biases. Why? Because I wanted to learn faster, and I was like, I'm going to be up against people with bigger computers, so I need to find ways to learn faster. But if you're trying to find some ultimate truth, like some beautiful strategy in Go that no one's thought of, then maybe it is the right approach to remove the bias. I don't know. I think it depends on what you want to do. What do you think, Eric?
Yeah, that's interesting. I'm against looking at humans as a source of inspiration because for numerous reasons. Yeah. Yeah.
I mean, to me, that sounds like a bitter lesson type thing, right?
Yeah, I think so. I mean, I see where people are coming from, in that like there are people in our lab say that humans are like our only real proof of existence for intelligence, so one of the main proof of existence for intelligence. So we should look to them for what to maybe model our agents on or not. But in my mind, for a lot of the problems we're solving, humans don't actually do, or the hard problems humans don't actually do a very good job with. And like my goal for AI is not simply to recreate humanity, but like on an SSD, I'd rather figure out what problems we're interested in solving and then solve those problems and not get too married to one solution method. Like,
sorry, what did you say about SSD?
I said I don't want to recreate humanity on an SSD. I would prefer to create something new or better. Actually solve the problem instead of come up with some of the hacky heuristics that humans follow.
I mean, a lot of the problems we have are because of our own bias and social problems. So, I mean, even if the AI isn't constrained by those biases, it still might be good if it understood them, so it could help us compensate for them in some way.
I suppose that's true, yeah. Right, like incorrect generalization being root of a lot of problems. Yeah, interesting.
We have some comments in the chat. Ashley saying, is using humans as a model for intelligence too narcissistic?
I think so. I think it's giving us too much credit if you see the way that people, when we're put into like new situations, fail a whole bunch, or even like I wouldn't want a self-driving car that was at human levels of performance, because then it would still kill like thousands of people a year. So I would prefer to have like superhuman performance, and I don't want to get stuck basically at human level performance by sort of mimicking things that humans do.
And then Patrick says humans are also incrementally getting smarter, hopefully also incrementally more wise. 2 timescale problem. Can you say more about the 2 timescale part?
I think the best reference would be to King Lear. So we can always go back to some of the comments of the Fool and King Lear. But well, some of you folks have already heard me give talks on intelligence amplification. Humans are a good starting point to understand how intelligence Lego blocks with other intelligence, or how things might fit together. So, I mean, you can aim for big knowledge bases. You can aim for abstracting things away, like the sum total knowledge on the internet, and then hope that you get some good distillation out of that. But in the end, you might get differences between your intelligence perk points and your wisdom perk points. I think there's some things that we aren't capturing in our model. Like, Eric, maybe some of your opposition to modeling after humans is that maybe we're modeling certain aspects of humans, but we're failing to model the empathy and compassion aspects of humanity that might be the good things to model, and instead are modeling what we consider to be the knowledge bases of our species. And maybe there's important distinctions to be made there.
Yeah, it's an interesting point. Like condensing all of the text on the internet into a language model, and then seeding it with things and seeing what it says and taking that to be some sort of condensed truth about the world seems extremely problematic and dangerous to me. Like, that's just saying what other people have written on the internet and taking that as a true label for how things should be or are currently. And I don't know if you've seen what's on the internet, but I'm not a big fan.
They're really nice to each other, and it's just great.
That's right.
It's like thorns and roses.
Yeah, I don't really want the next generation of AIs to be trained on 4chan, frankly.
Yeah, I guess I think in terms of GPT, like I think like my personal opinion is those type of models could be useful as some kind of prior, but it's silly to think of their output, whatever's spewing out this random output, is that it's super meaningful. I mean, it's cool, but it's, yeah, and I'm trying to think of how different ways of combining it with our, like GPT is just such an uncontrolled stream of just spewing stuff out, right? There's the way to control it is just very weak.
Yes. but people treat it as though they view it with the popular culture at like idea of artificial intelligence. So they ascribe much more knowledge and mastery to it than they really should. And I think that's going to be amplified by OpenAI trying to commercialize its API so that you can access it for all kinds of things. And then you just trust those outputs and you just make decisions based on it. And because it can generate things so quickly, you're going to be at huge scale. You're going to be able to scale up any problems or any harmful things that it does. Yeah, I find that really worrying.
I mean, this is a problem even with very technical people. Like, so there was a demo of GPT-3 in the Vantech machine learning group, and someone had it up on the screen, and we were talking about the time. We were talking about time, and most people seem to think that GPT knew that it was 2020 right now. And I was like, why would it think that? Because it has this huge corpus. So I was like, let's try this. So I was like, just write the current date is. And so they put the current date is, and it said it's like October 2016 or whatever, right? But why is that meaningful? It's not really. But it's just the assumption of the group that, oh yeah, it would know that it's 2020 now.
Yeah, but that's just the number of times that the current date is, and then some date came up in the training set would have been apparently in 2016. That's yeah, that's a little bit, that's very interesting to me, because I think that's a big problem with supervised learning methods in general, is that they take what currently exists and they imply that that is some underlying truth, or it's the way the world has to be. There's no real counterfactual stuff going on there, which is pretty worrying.
Yeah, you use the C word.
Yeah, I have a comment on this C word thing. So there's this thing, well, a different C word, Conway's law, right? Conway's law says that organizations design systems that reflect the hierarchy of the organization. And in machine learning, we seem to have this dichotomy between RL and supervised learning, or at least people see it that way. And then I'm looking at many of the systems we have, like DQN and all of these things. And they also seem to have like a supervised part and an RL part, right? So I'm wondering what your thoughts are on like how the organization of the machine learning researcher sphere is affecting the design of the systems that we build, like whether that's good or bad or whatever.
I love that question. Are you asking me, Roshan?
Yep. You're on the spot. All the questions go to you.
I can't believe you're asking me this. Okay, so I actually have a strong opinion about this. I think that I think you really want to surround yourself, if you're doing RL, you want to surround yourself by people who are freaking ninjas at function approximators, at different types of supervised learning. And I don't know if that's always the case, but it seems to me that's not always the case. But I think the interface between the very cutting edge on these different function approximators and then how that applies to RL, I think is kind of important. And I feel that, yeah, for example, like when Danajar Hafner, who works with Jeff Hinton, when he talks about RL, he's coming from a place of incredibly deep understanding of the neural network stuff, and he's able to bring that in a different way. And then there's other people who work with more exotic function approximators, like, you know, Taylor Killian has this paper where he's using differentiable decision trees. So taking decision trees, but now making them differentiable, and they're much more optimal than regular decision trees, but you can use them in deep RL, and because they're decision trees, you can interpret them. You can just literally read them and explain to a doctor what it's doing. So these types of things are kind of like superpowers that I think are possible only when people get very deep into the function approximator. And then also there's this crossover between, yeah, there's just, I mean, in one monolithic agent, you can have supervised and unsupervised and are all happening at once in one network. Which I'm sure a lot of people know, but it doesn't really happen that often. So guests number 3 were Ashley and Antoinette, and they made stable baselines, and they also made this unsupervised learning thing to stick on the front of it. and that allows it to handle very high dimensional problems with ease because this unsupervised stuff factors it down. So I think there's so many ways to combine the different parts of the cake of Jan LeCun's cake in different ways. I don't think he has it very distinct. Like this is a layer and this is a separate layer, and maybe it doesn't have to be such separately. Maybe it can all be kind of baked in. Does that answer? Well, it's just my opinion. I don't know if that answers your question.
No, I would say that your opinion should be fact. Like that's just the way it is.
So when I said C word, I actually meant counterfactual, because Eric said, "Oh, you can do a counterfactual thing," and so actually I was interested in, like, Eric, do you think the counterfactual thing and the causality and causal models are an important thing to work into this framework from your point of view, or is that where that's coming from, or you had a different point of view on it?
I'm not really sure, because I guess the problem I was thinking of is that when labels are assigned, they're assigned by some human with some understanding of how the world is. So even something like MNIST, you see these numbers assigned, and if you look at the actual, like they're assigned some label, if you look at the actual data there, you can see things that are extremely ambiguous that probably many people would disagree as whether it's a 1 or a 7, or yeah, whether it's like a 9 or a 7. Some of them are really, some of them are also just like straight up wrong. If you look at them, there's a couple in every like data set. So it doesn't seem like that is a way to, like that just says how the world is, or how the world is through one person's eyes. It doesn't show you any like deeper understanding of how things could be different or how things might be different. Maybe MNIST isn't the greatest example for that, but certain things like that paper that somebody put out claiming that they could predict criminality based on pictures of people's faces. And that was just like, okay, they're taking historical data, which has like so many problems, and they're just treating it as the ground truth. It's just the labels, right? It's the ground truth labels. And then they're regressing on that and finding features that correlate with this historical data. And clearly that data has a lot of problems with it. So it's not a ground truth, right? It's just what happened in the past, and what happened in the past was like straight up wrong, and we don't want to continue that in the future. At least I don't, and I don't think many people do. So the issue I have is that a lot of the supervised learning techniques, they just have this, not understanding how the world works, not understanding what aspects of the world could be changed. They're saying that if this is really fundamental underlying truth, then we need to keep doing it in the future, which is like very dangerous, because I don't think there's many things from a social point of view that we know of that are ground truths. So I'm not sure that I have a solution to this problem. I'm more pointing out that there are. I'm not saying counterfactual reasoning is a solution to this problem. I'm more saying that people who are making these, I guess people shouldn't be making these giant, I guess these giant models that are inscrutable and have no like ability to say why they're doing things, or say what could be done differently to change things. They're not really understanding the world, which I think is very important to have centers, like front and center for everybody to understand, but I don't think that enough people ever emphasize that.
I agree with you. I mean, I think the example you used is like a poster child for causal models, because basically, the shape of someone's face isn't causing the criminality.
Right.
There might be some other socioeconomic factors that are causing certain races to be associated with certain policing techniques or whatever that's leading to this situation, but it's not a cause. It's not a cause-effect thing, and therefore the model is modeling an association and not a cause-effect.
Yeah, that's a good point, actually.
So the causality gives us the vocabulary to express these problems very succinctly.
Well,
I mean, even this is not a rare problem. Even in Neurips 2019, there was a poster on predictive policing, and people were heckling this. I mean, so the poor woman is giving her poster session, but basically she is basically saying we should be doing here I'm presenting my predictive policing model, which is saying, you know, areas where there's crime, we're going to send more police cars. And we were all heckling her. But how did she get in there in the first place? So how did she get to that point without anyone telling her? Go all the way into Neurips poster session. So it's not a small problem. Yeah, I think the whole idea, the whole cottage industry of explaining ML to people has to even be done within the ML community.
Yeah, that's true. I think it really doesn't help when you have super big or really, I guess maybe not large, but front and center hyped actors in the industry doing things that could be used like this. Yeah, I'm really not sure what a good solution is aside from just like screaming it from the rooftops for everyone to hear, right?
I wonder at the same time how much of this is like coming from the methods themselves and how much of it is coming from the way that computer science is just taught in general. Like there's a little bit more of like academics are starting to like promote the idea of like not only teaching computer science as a pure science, but also do it as a social science to give students a notion of how the algorithms that we work with in the end are going to be shaping the society that we live in, right? Even if you are working on the most like trivial algorithm and implement it in the real world, we're so connected to our technology that's going to end up shaping the way somebody lives. So I wonder, like, is this really a problem of the methods that we design, or is it more a problem of the way that we educate computer scientists?
That's a great point. Like, did that woman presenting that poster, is that on somebody else to tell her that this is not okay, or should that have been part of like the graduate curriculum to have ethics courses and understand the ramifications of making these systems that can scale to affect millions of lives? That's something that I think is really, really badly lacking in not just our department, but I think in many of the departments, from people that I've talked to, they don't seem to do a great job with this. There's a program called Humanities Computing at the University of Alberta that is basically attempting to look at how computing, AI, any of these technologies affects humanity, and looking at it from more of a social sciences perspective. But as far as I can tell, like nobody in CS knows about them or collaborates with them, which is frustrating.
Yeah, I have to bring it back to the causality thing. So I'm taking a course right now with a professor in Boston who does PhD on causal models for like biology or whatever, and yeah, with these methods, you can, within a diagram of like 4 lines and circles, you can explain the problem very clearly. Why is that a problem? Why is it bad? And how to work around it. And so even I think there's I think it's still not a widespread thing to accept that it's very important to understand that point of view. And so it's not really in many curriculums yet. And that's actually why I'm choosing to learn it right now, because I'm looking for things that are like understudied. And I still consider RL kind of like that, even though it's flooding in the ML research areas. It's not really that much outside of it. But the causal models, I think, and this is Judea Pearl's approach, is the structural causal models. And then there was the older paradigm of the potential outcomes. I think they're both interesting, but the structural causal models are the ones with the diagrams. And they would help you. So you could say, you know, this is the genetics that causes the person's face to look like this. And then these are the other factors, and you're modeling this arrow, and we don't want to model that arrow, and this is the reason why we don't model it. So I think there's a combination of what Fernando was saying about the social science side, combined with a simple causal diagram to make it very concrete, and that can actually allow, when you incorporate that into your ML, then you can actually allow your ML to to make use of those causal facts, which I don't think causality is something that we are bringing to the table. I think it's very hard for algorithms to learn causality in the world because the world's so complicated. So I think there might be a way where we bring the some of the causal model and then the ML, like bringing that together with ML to make models that are not so stupid and make these horrible association mistakes.
So RL is sort of a very simple causal model, right? Like the causality in at least online reinforcement learning is that the actions are totally under the control of the agent. Like the Markov property is a causal claim, right? But I guess my question is, yeah, and so I guess the debate is, do we need more complicated causal models? Because the consensus, like I was just talking to somebody who's working on causality like just a few hours ago, and they thought that the problem with very general causal models is that they're just too complicated. You can't learn them. And so you adopt a specific causal model, which I think is what you were getting at, which is that humans decide what the causal model is, and then the machines just kind of learn the parameters, right? But I guess the natural question that arises from that is, if learning causal models is so hard, then how come humans are able to do it? And maybe, and then there's two answers to that. Maybe there is something about humans learning causal models that is hard to replicate in machines. That seems weird. But other possibility that humans are also learning the wrong causal models. And so maybe then you don't want the humans dictating the causal models that our machines are bound by. Maybe the machines would be better at learning causal models. And then there's yet other question of, even if you design a machine system that you have not explicitly designed to learn a causal model, maybe if it is an RL system, it is learning a causal model anyway, right? Because it has to learn about its actions and the consequences of its actions and how they affect the world and so on. So yeah, anyway, this was very long and rambling, but I think there's lots of intersections of causality and RL, but also social impacts.
But I mean, I think that RL would fall prey to a Pavlovian response, right? Like if the agent sees the bell rings every time it gets a food, then it starts thinking the bell is causing the food.
Oh, sorry, I meant control in RL, not just prediction. So control. So generally with causal models, it's almost impossible. Like causal models are hard to learn anyway, but it's also impossible to learn causal models with just observational data, right? You have to have interventional studies. And prediction in RL is basically observational data because there is no control, right? It might be extended over time, but that is still a very different problem from control in RL, where you actually have to learn about the consequences of actions. Like if I made this action, would this happen, right? And that's where counterfactuality comes in, and that's where causality is really important, right?
Mm-hmm. But then we have this common sense to make it easier for us to learn these causal models that I think our agents don't have that. So we have like general principles and like a hierarchy and taxonomies of knowledge that we can use to guess what's going to happen in a way that I've never seen in an AI system. And so we can be more, I think we're much more informed. We have so many priors about causality as opposed to just trying to learn a raw structured causal model from a table of data. We have so much priors to help us. Maybe that's part of it.
Yeah, and I guess my argument was that is what is the problem, because in many simple tasks like the physical world and so on, our priors are actually helpful. But for example, if you talk about a lot of social impacts and you talk about, like you ask many people what they believe about, for example, race causing crime, people actually believe very silly things, right? And they have for a long time. And in fact, it is taking a lot of effort now in the last few years for people in the social sciences to sort of convince the world at large that causality doesn't work the way they think it does. So maybe our machines would be able to avoid that right away. We have a lot of prejudices against people, right? Like for and against people based on how they look and how they act and whether they're part of our in-group or not. Those are also prejudices that are going into how we build our causal models that many people find very hard to get rid of, regardless of how much ever evidence is presented to them, right? Just yeah.
So when you talk about human causal models that humans have, I mean, we each have our head full of these models, and any random person on the street is going to have maybe a very vague model about something, but someone who's really studied it in depth is going to have a very high resolution model and more correct model. And we have no
more high resolution, but not necessarily correct.
Oh, you're saying even people who study that
Yeah.
may also be incorrect.
Right. So, for example, I'm sure the KKK had a very detailed causal model of all the ills caused by people of, dark skin. I'm sure they were very invested in that. They had spent a lot of time thinking about it, but they were still wrong. At least I think they were wrong.
For sure. But do you think there's some people who have a more correct causal model in their head? Like, if we could agree on that, then we could try to combine the causal models of the people who have the most correct ones.
Right. So it depends on what you mean by most correct, because usually with causal models, you're talking about counterfactuality. And if you could actually change the world in any way and observe the consequences, then maybe we could learn more correct models. But in reality, you can't do that, right? So when you're reasoning about counterfactuality, then there is so much sensitivity to sort of pre-existing biases. Like, the number of possibilities is so large, right? So, for example, let's take some political question, right? Like, I don't know, healthcare or something, right? So you could ask, would having socialized healthcare be good or not? But the problem is you have to answer this question without actually, like, before you actually implement it and see. So what do? You can say, okay, if I look at this country, it seems to be good. But then somebody else says, but if you look at that country, it seems to be bad. But then you say, okay, but this country is more representative of our situation for X, Y, and Z reasons. This other person says, but this other country is more representative for X, Y, and Z reasons. And the third person says, our country is totally different from all of those because we are unique in this way, and so on, right? So the connection between evidence and conclusion becomes much weaker when you're talking about counterfactual reasoning, because you have to talk about generalization and similarities and sort of understanding root causes and so on. And all of these things are not directly observable. And if you had infinite intervention power, where you could just spin off alternate universes and try things out, you could maybe learn them. But that is one of the reasons why there is so much disagreement, right, amongst rational people on these topics, because you'd actually have to do the experiment and see, and that's hard.
So what you're talking about sounds like econometrics and synthetic controls.
And reinforcement learning and control in reinforcement learning. I think we are starting to understand that the hardness of reinforcement learning is sort of, or control in reinforcement learning is indicative of these sorts of problems. And that is like a fundamental information theoretic hardness. It's not going to go away. Sorry, I interrupted, but yeah, I think there's a ball of hardness, which we have to recognize.
But somehow, like, good human leaders are able to guide us through, even with all that uncertainty. Anyways. Fine.
Yeah, but maybe in hindsight, we say that leaders were good when in hindsight we realize that they guided us through. But in the moment, people have different opinions of what a good leader is. They might disagree. And who knows whether who's right and who's wrong. I mean, of course, I'm right and you're wrong. But like, from a more objective point of view, who knows who's right and who's wrong, right?
Good point.
Can't argue with you, Roshan.
Yeah, I guess what I'm saying is, like, I'm arguing for the hardness of arguing with people, right? That's an easy argument to win.
Roshan 2020, you got my vote.
Well, definitely RL is still relegated to very high data environments. And so whether we could ever bring it to some environments like you're talking about, could it decide whether to make free healthcare? It's that's not really, maybe that's not an RL thing so much as a, like you're saying, a counterfactual model has to get really great models of society, like the psychohistory thing from Asimov.
Interesting talk, though. Yeah, thanks a lot for giving it.
Thanks so much for having me. I really appreciate it. Abhishek, thanks again. And big fan of Amii Tea Time Talks, and I have been for years, actually.
I also wanted to say that I hadn't listened to Robin's podcast, and now I have at least a few episodes, and I can highly recommend it to everyone here. Normally, I don't listen to podcasts that are close to what I work on, because it's like, that's work. Why would I also spend my fun time listening to that? But I think Robin's podcast is like an exception to that rule. So I don't know if Robin will plug it, but I'm going to plug it on his behalf.
Oh,
Awesome.
thank you. Thanks so much for saying that. And you can, I just put the URL up. You can see it. Thank you, Roshan. And Roshan, I'm looking forward to having you as a guest whenever you're ready.
Sweet.
All right. Thank you so much, Robin. It was great having you for a tea time talk.
Thank you.
See you all next week. No, tomorrow.